Hey guys, hope you're well. Listen carefully to this introduction because in this paper, it was written in November 2022, there was a specific question, specifically question 5.1, where the question paper had a mistake. And I don't know if you saw this, but it made the news and there were a lot of students, thousands of students that were upset. So I'm going to quickly show you that question. So this is the famous question, and there is a mistake in the question. So what we're going to do when I do this question with you later is we are going to change this from a +3, and we're going to change it to a -3. If we do that, then the question does work. But by putting it as a plus, the question is literally, it makes no sense. Because this information and this information, they would not work nicely together. So we're going to keep it as a minus. Okay, but when we get to that question, we'll talk about that then. Besides that, the rest of it is all good. So this was the November 2022 grade 12 maths paper 2 exam. 150 marks, 3 hours. If you want to download the paper, just check the description below this video. With this question, there are more questions coming up on the next slide. So here we've got 1.1, 1.2 and 3, 1.4, and then 1.5. So it's a 5 question question. So let's have a look. The matric class of a certain high school had to vote for the chairperson of the representative council of learners. The scatter plot below. Okay, wait. The matric class had to vote for the chairperson. The scatter plot shows the IQ of the 10 learners who received the most votes. Geez, okay. So it's quite a personal thing. They're looking at their IQ and everything. Okay, so pretty much there is some people who have, there was a person who has an IQ of 108. They received 10 votes. Then, for example, there's a person with an IQ of 119 and they received like 12 votes or something like that. Okay, so make sure you understand what this is telling you. They're pretty much looking at the IQ of individual learners, and then they're looking at what number of votes did those people get. Okay, now it says here, before the election, the popularity of each of these 10 learners was established, and a popularity score was assigned to each of them. The popularity scores, and the number of votes. Okay. So here we've got a popularity score. So what we can see is that this person over here has a very high popularity score, and we can see that they also have the highest number of votes. They have 22 votes. This person over here also has a very high popularity score, and they have a very high amount of votes. This person over here does not have a very high popularity score, and so look, they don't have a lot of votes. So what this table is trying to show you is that the more popular you are, the more votes you get. Okay, that's what it's sort of trying to show. And then this one is showing the intelligence and the number of votes. Okay, so the first question says, calculate the mean number of votes that these 10 learners received. So you could do this in multiple ways. Well, there's 2 ways. You could read it off here, or you could read it off here. Now, I don't know about you, but I like to read it off over here. I don't know why I went slightly American over there. Like, I'll be damn, boy. I'll be doing this one over here, son, while I don't down yonder down here. So let's carry on. So we're going to be doing this one over here. We're going to calculate the mean number of votes, and I'm going to use these numbers. And I'll show you that these numbers here are actually the same as these ones. For example, the 9, number of votes, 9, would probably be that person over there. And then is there a 22? Or let's go to 22. No, that's 21. There's a 22 over there. You see, if you draw a line across, I know I haven't got this very big, but I wanted to fit everything in. But that over there would be a 22. Okay, so these numbers that you see here are also going to be over here. So to calculate the mean, well, we know how to do that. Mean is just where you go add all of these numbers together and then divide by how many there are. So we will say 9 plus 22 plus 10 plus 21. Okay, you get the idea. Okay, you're going to add all of that together. Let's just write that a little bit better. 19 plus 16, and then you're going to divide by how many there are. 1, 2, 3. Oh, they said there were 10 learners, hey? So we divide that by 10, and if we had to work this out, you would end up with, well, it's 155 at the top and then 10 at the bottom, and that would give you 15,5. So that is the mean number of votes. It's the average. Then this question says, for 1 mark, what is the standard deviation of the number of votes that these 10 learners received? Okay, now it's only worth 1 mark because we're going to do it on our calculator, okay? On a Casio calculator, it's really easy to work out standard deviation. So pretty much what you do is you put your calculator into stat mode, okay? And then go to the one that says 1 minus VAR. If you're a grade 12 learner, you would only use the A plus BX if it was like a grade 12 kind of question. But this is actually a grade 11 kind of question. So you say number 1, 1 minus VAR. Now you're going to go put the numbers in. So for example, you'd put the number 9, press equals. Press number 22, press equals. You get it. Number 10, press equals. And then you would just go fill in all the values. Okay, and then there I put in the last value, so I press equals. Then I press AC. Then you press shift, and then you come down here to the number 1, and then it gives you all these options. Now we're looking for variance, VAR, and then you're looking for the funny sign that looks like an apple. That's your standard deviation. So you press 3, and you press equals. And if you round that to 2 decimal places, we will get 4.59. There we go. This question says, or let me just quickly write down our standard deviation, 4.59, just in case we need that for a different question. The learners who received fewer votes, oh, here we go, then 1 standard deviation below the mean. And remember what we got for the mean? That was 15.5, and then the standard deviation was that. The learners who received fewer votes below the mean were not invited for an interview. Wow, that's harsh. How many learners were invited? Okay, so there are 10 learners altogether. Now, if a learner is receiving too little votes, they're not going to interview that person because, you know, if they're not getting that many votes, then why would they choose them to be part of the learner council? So what they're saying is that the average is 15.5, okay? So then they're saying the learners who received fewer votes, so less votes, then 1 standard deviation below the mean. So what I'm going to do is I'm going to take this number and then I'm going to subtract 1 of the standard deviations. If they said 2 standard deviations, then you would have just done it twice. You would have just done another one like that, okay? Now you're going to press equals now, and you get 10.91. So anyone who receives less than that, they are not going to invite. So this person received 9 votes. Sorry, buddy, you're out. This person receives 10 votes. Sorry, you're out. And this person is fine. Okay, so those 2 have been eliminated. So how many people are still remaining? 8 people. How many learners are still invited? 8. Okay, now here we're going more for grade 12. Determine the equation of the least squares regression line. So remember, the equation of that is A plus BX for the data given. Now, to find the value of A, it's actually a capital A and a capital B. To find those values, you use your calculator. Okay, so we still have the values in the calculator. And so we're then just going to go mode, and then you're going to press the number 3 for stat again, which we already were in. But now you're going to go to the A plus BX. You see there at number 2, A plus BX. And here you've got X and Y values. So the X and Y values are these ones, X and Y. So for example, you'll press 32 for the X value equals, and then the Y value would be a 9. Now you can choose. I like to put all the X values in first. So I'll go 89, 35, 82. And I'll do all of that. And then I'll do the Y values. So you can obviously pause now if you want and just go enter all the values. So there I've done all my values. Once again, I'm going to press AC. Then I'm going to say shift and 1. And then I'm going to go to 5, which means regression. And then there's the values that I would want. So to find A, I would press number 1 equals. And then, okay, so you would write that down. I'm just going to write it down on a piece of paper so long. 7, 7, Okay, and then we're going to go find the value of b. So you'd press shift 5 for regression, and then we want the b value. So we're going to press number 2, and then we're going to press equals. And there I'm just going to write that down quickly. And so what we found was that a was, I'm just going to write down the first 4 decimals, 1.7709, and then I'll just write those down. And then b was 0.2243. But when you write it in your equation here, you just need the 2 decimals. So for a, you would round that to 1.77, and for b, you're just going to keep it as 0.22, and then x. So that is the equation of the least regression line. Okay, so this question says, predict the number of votes that a learner with a popularity, now popularity is a x value of 72. So what you'll do is you'll just put a 72 over there. So you'll just say 1.77 plus 0.22 times by 72, and then you'll just go ahead and write that or type that on the calculator. And they're saying about 17.61. But now you can't get 17.61 votes, so you would round that up to the nearest whole number, and that would be 18 votes. 18 votes. Okay, these questions say, use the scatter plot and the table and provide a reason why the IQ, so it's this one here, is not a good indicator of the number of votes that a learner could receive. Well, I really like this one, because this one seems to be showing a very good correlation. For example, if your popularity score is low, then your number of votes is low. If your popularity score is high, then your number of votes is high. If your popularity score is low, then your number of votes is low. If your popularity score is high, so this one shows a very good relationship. But this one's completely random. Here you have a person with a very low IQ, and they have a very low amount of votes. But here you have another person who's got a very high IQ, or it's higher, and their votes are also very low. Here you've got a person who's got a IQ of about 100, and look at their number of votes. And then here you've got a person with a much higher IQ, but they've pretty much got the same amount of votes. So can you see here that whether you have a high or low IQ does not seem to be affecting the number of votes? So this one is not showing a good relationship. There's no clear pattern over there. So what we could say is that the data is scattered, or is randomly scattered, and no correlation exists. And then this last one says, why was the prediction in question 1.4 reliable? Remember in 1.4 they said predict the number of votes that a learner with a popularity. So they were talking about this table. And what we said was this table looks very good, like there's a good correlation, but you can't just say, oh, it looks good. You have to prove it. So we need to go and calculate a certain value. I wonder if you know what that number is called. It's a certain letter or a certain number that tells you whether this information and this information are having a good correlation. Well done if you remember that that is called the value of R. Now we're going to go find R on the calculator. So here we still have the calculator, and so you've still got all your values. So you're just going to say shift there, then you're going to go to 5 for regression, and then you're going to type in 3 for the R value, and you're going to press equals, and look at that, 0.98. So remember that we've made videos, and I'm sure your teacher's spoken to you about it, and I'm sure your textbook explains it. The R value, for different R values, it tells you whether there is a good correlation or a weak correlation. So what we just found was that R is 0.98. So let's go on to this question now. I don't know why it's only worth 1 mark and they're expecting you to do that, but you do have to do that. I even checked on the memo to make sure, because I wasn't sure why they're only giving us 1 mark. But anyways, so R is 0.98, so there is a strong correlation. With this question, there will be more coming up on the next slide. So you see there's 2.1, 2.2, and 2.3 over there, and then 2.4 and 2.5. So it says that a company conducted research among all its employees on what percentage of their monthly salary is spent on fuel. The data is represented in a ogive. Okay, so here you've got percentage of salary spent on fuel and then cumulative frequency. So it says how many people are employed. Well, that's easy. You just go to this very top number, you look over there, and that'll be 60 people. Okay? Write down the modal class. Now, you've got to understand your grade 11 statistics very well to be able to answer a question like this. You have to understand the way that your frequency tables work, for example. So I'll quickly show you. I'll reverse this thing for you. So if you were given a frequency table, it would have looked like this. It would have been percentage on fuel, and you would have had 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25, 25 to 30, and 30 to 35. Then they would have had a frequency value, and then they would have had a cumulative. Now I'm going to go fill in the cumulative because they've got it here on the y-axis. So the cumulative for this one would be 0. Then for the 10, it is going to be, I don't know if that's in between. Yeah, let's take it as in between. Okay, so that's going to be 2, 4, that's going to be 5. Then this one is 12. Okay, let's maybe make lines over here. You wouldn't do this in a test, by the way. I'm just reversing this whole thing so you can understand exactly where these numbers are coming from. And then this one here would be 24. Okay, and then, whoops, we've done that one. And then this one here, now this one's in the middle. So it's between 42, 44, 46. So it's going to be 45. Okay, 45. And then this one is going to be on the line there. So that's 58. And then 60. Okay, now that means then that this number would have to be a 0. This would have to be a 5. Now, you know how to go from, you've been taught how to go from frequency. Whoa, what happened there? I didn't even press the eraser. What? Okay, anyways, don't know why this thing is glitching like this. Okay, so let's just go down. There we go. So you know that, I'll show you now, this would have to be a 7 because 5 plus 7 is 12. Then this would have to be a 12 because 12 plus 12 gives you a total of 24. You know how cumulative works. And then this would have to be 21 because 24 plus 21 is 45. And then 45 plus 13 would have to give you that, and then 58 plus 2. So the answer, where do we find the most people? Well, the most people is going to be this category over here. Let's rather get a highlighter over there. And that's the 20 to 25. So that's from here to here. We can also see that that's the largest gap. Can you see there? There's a large gap over there. If you look from there to there, there's a big gap. Whereas if you look at some of the smaller ones, from here to here, that's not such a big distance. From here to here, that vertical distance is not that much. From here to here, it's over there. And then from here to here, look how big that is. You see there? A lot of people in that category. And then there, not that many people. Okay, so the answer is going to be from this category to this category. So that's going to be 20 to 25. This next one says, how many employees spent more than 22.5% of their monthly salary on fuel? So what we'll do is we'll go to 22.5, which is exactly in between over there. You'll then go up to where it meets the graph, which is over there. And then you would go across. Whoopsie. Let's go across. And that comes out over there, which is going to be 34. That's not the answer necessarily. I'm just saying that that's where we get it over there, 34. Yeah. Okay, so it's 34. Let's just write that down nicely. 34. Now we're going to read the question. How many employees spent more than 22.5? So we've just looked at that area there. So this part of the graph over here would be all the people that are less than 22.5, and these people would be more. So we know that there is a total of 60 people. Up to here we are at 34. So that means the amount of people over here would be 60 minus 34, which would be 26 people. And if the question said less than 22.5, then it would be all of this, and that would just be 34. Okay, so always read those questions carefully. Let's carry on. An employee spent 2,400 Rand of his salary on fuel. Determine the monthly salary if this employee spends 7% of his salary on fuel. So 7% of the salary is going to petrol. So there's an equation. 7% of the salary is going to petrol. So we know that of means times. The salary, we can call that X, and the amount of petrol is 2,400 Rand. Now, 7%, you can write that as 0.07. So then this can just become 0.07x. Then to get x by itself, you can just divide both sides by 0.07 so that cancels. And so x would be 34,285 Rand and 71 cents. So that is the salary that this person earns per month, and then they spend 7%. So 7% of that will give you the 2,400. Okay, this question says the monthly salaries of these employees remains constant and the number of fuel used also remains constant. Okay, so for example, what they mean is this person earns 34,285 Rand and 71 cents every single month. It's not some months is higher, some months is lower. It stays the same and the petrol stays the same. So if the fuel price increases from 21 Rand 43 to 22 Rand 79, how will the above ogive change? Well, let's think about this, guys. The salary that let's just use this person as an example. The salary is not going to change, but the petrol price is increasing. So, and they're still going to be driving the same amount, for example. So they say that the number of liters of fuel stays the same. So are they going to now be spending more or less on petrol? Well, more, because the petrol price is increasing. So the percentage of the salary, so that, let's say, for example, this person was spending 2,400 Rand, and that was 7%. Now they're going to maybe go up to 2,600 Rand, for example, for this person. So that's going to become a larger percentage. So all of these values, they're all going to go more to the right because the percentage is going to increase. So this entire graph is going to be shifted to the right. So we could say that the graph will shift right. With this question, there will be other questions carrying on in the next slide. So we've got the first bunch of questions over here, and then we've got more over there. In the diagram, I'm just going to see what's important here. Are vertices of a triangle. Okay, obviously we can see it's a triangle. T is the midpoint, okay, but we can see that because they're showing us that over there, so that's not information that we actually need to know because we can see it. The equation of the line AC, okay, this is important. The equation of the line AC, okay, is 5x minus 6y equals to 8. The angle of inclination is alpha. We can see that. Triangle DCT is drawn such that CD is parallel. We can see that. The line AC and DC intersect at S, of course. The y-intercept, okay, which is the y-intercept. Okay, so S is on the y-axis there, and then those are the x-intercepts of those, and those. Okay, so not all of this information was necessary because it's already depicted on the diagram. The first question for 2 marks, calculate the gradient of AB. So the formula for gradient is y2 minus y1 over x2 minus x1. So if we want to find the gradient of AB, where you AB here. Okay, so for example, I will label, let's get rid of all this. I'll label this as number 2 and this is point number 1. So if I fill in the formula, it'll be 2 take away negative 4. You see how I've just put the two negatives like that? And then 4 take away 6. And if we work this out, you'd get a 6 at the top, a negative 2 at the bottom, which is negative 3. This question for only 2 marks, the size of angle alpha. So we know that there's this thing where we've got tangent, or tan, sorry, gradient, and inclination angle. There's a relationship between all of those. What I mean is the following. If you have the gradient, then if you use tan, you can get the inclination. So tan, if you use tan in the gradient, you could get inclination. If you know the inclination, then you could use tan to work out the gradient. So there's a relationship there. So we now know that this is the inclination angle. The inclination angle is always, and I repeat, always the angle on the right-hand side. So for example, where this part intersects over here, there's an angle on the left and an angle on the right. The inclination, by definition, is always the one on the right-hand side. Okay, now, we already know the gradient here is negative 3. Ignore the negative for now, and what you'll do is you're going to go say shift tan of 3. So shift tan of 3 on your calculator, and let's see what that gives you. That'll give you 71.57. Now, okay, so now that's not the answer because we used positive 3. Now, you know how in general solution, whenever we are busy finding the reference angle, let's say you found something that says tan of some angle was negative 3. Well, you wouldn't type in the negative on your calculator, and that's also what I told you what to do over there. But then what you would then do after that is you would then go work in the quadrants where tan is negative. Now tan is negative if this is quadrant 1, 2, 3, and 4. Tan is negative in quadrants 2 and 4. But remember, with tan you only have to do one of them. So what we'll now do is we'll say, okay, so that angle must be equal to, now we're going to go into quadrant number 2, which is the 180 minus quadrant. So we're going to say 180 minus, and then 71.57. And that'll give us 108.43 degrees. And so that would be this angle over here. So we're going to say 108.43 degrees. The next question for 2 marks, calculate the coordinates of t. So t is the midpoint of those two. So we'll just use the midpoint formula. Now remember, the midpoint formula goes x1 plus x2 over 2, y1 plus y2 over 2. So the midpoint of t would then be, so I'll call this number 1 and I would call this number 2, but you can do it however you want. And so the x value of point number 1 is negative 2, the x value of point 2 is 6, divide by 2, and then I do the same for the y. Minus 3 plus minus 4 over 2. You see, I don't worry about, I know that the formula has a plus there, so I put a plus there. And then if this is a negative 4, then I just put a negative 4 there. I don't worry about, but is it going to become a plus or minus? The calculator can do that nonsense for me. And so then we just end up with, this would become 2. And then this part over here would end up becoming negative 7 over 2. So it's going to be 2 and negative 7 over 2. This question says, what are the coordinates of S? Well, we know that it's on this line. You could also say this line, but the reason I'm choosing this one is because we have the equation. Now, what is S? S is the y-intercept. How do we find the y-intercept? Well, for any equation, you make your x equal to 0. And you can make the x equal to 0 straight away. You don't have to first rearrange this equation to become standard or like y equals to mx plus c. You can if you want, but you're wasting time. So you could just say 5 multiplied by 0 minus 6, y equals to 8. That'll give us negative 6y equals to 8. divide both sides by -6, and we should simplify that to -4/3. It would eventually simplify. Actually, I get a lot of questions from learners saying, Kevin, I don't know where the 4 and the 3 came from. So let me show you like that. Okay, it simplifies. Now, when they say give the coordinates, remember to give x and y. So we know that at that point, the x is 0, and then the y would be that. This question for 3 marks. Determine the equation of CD. CD, where you CD? Oh, here, CD. Okay, let's have a look. So we know that this line, CD, is parallel to this line. Now, when 2 lines are parallel, they have the same gradient. So if I can work out the gradient of this line, then, which we already have. Oh yeah, we already have this one's gradient is -3. So we can say y equals to mx plus c. Now, because this line and this line is parallel, we can then say that this gradient is -3. So let's tell the examiner that. We can say that the gradient of DC must be the same as the gradient of AB, why? Because DC is parallel to AB. So we can then say this. Now remember, to find this last part here, you just need to sub in a point on that line. So you could sub in any point on that line, and so we can just use point C. So you'll plug in the -3 at the y, and then the -2 at the x, and so you end up with -3 equals to 6 plus c. And so that'll give us, if you had to keep solving that, you would eventually get -9, and so y equals to -3x minus 9. This question says, for 4 marks, calculate the angle DCA. So D, C, and then to A. So that means this angle over here. So, whenever they ask for angles, it's typically you want to work in a triangle. But now this triangle over here would not be the best one to work with, because you could use inclination angles to find these angles over here, but that's not going to help you find this angle. So check this out. Remember, these lines, this one and this one, they parallel. So if you do alternating angles, then that means this angle is the same. So we can say that as our first step. We could say that angle FAR is the same as angle DCA because of alternating angles, because DC is parallel to AB. What this now means is that if we could just work out this angle, then we've got this angle. Now check this out. This one is in a perfect triangle, because what we can do now is we already know this angle, and then we can just go work out this angle over here by just knowing the inclination and the gradient and all of that stuff, and then we can use sum of angles in a triangle to find that one. Okay, so we need to go find the gradient of this line. There's no calculation involved. You can if you want to, but there's a better way. We already know the equation of this line. So what we could do is we could rearrange that equation to get it into the normal way. So we know 5x take away 6y is equal to 8. So I'm going to take the 5x to the other side. I'm then going to divide everything by -6. Like that. And that'll eventually, these two negatives will become a positive. And then this will simplify to a -4/3. So this is the equation of this line in y equals to mx plus c form. So it's y equals to mx plus c, and m is your gradient. So the gradient of, let's write it here, the gradient of AC is 5/6. So that means I could then use the gradient to work out this inclination angle over here by simply saying shift tan of 5/6, and that'll give 39.81 degrees. So this angle here is 39.81 degrees. Now, for this last part, there's multiple ways we could do this. Some learners are really good at, they understand that this angle on the outside of a triangle is equal to the 2 opposite angles added together. Exterior angle of a triangle equals to the sum of the two interior. But some learners don't like that strategy. So I will show the more common approach, which learners like to do, which is to then go find this angle over here. So we will call that angle FRA. And we'll just use angles on a straight line for that one. So angles on straight line. And so FRA is going to be 71.57 degrees. So this angle here is 71.57. So now we've got two of the angles in that triangle, and so we could find this one. FAR is then going to be 180 minus 39.81 minus 71.57, and that'll give us 68.62 degrees. Oh, but I should give a reason here. Sum angles triangle. And then we already know that, we already said earlier that this angle, this angle and this angle is the same. So therefore, and we already gave the reason earlier, so I'm not going to give that again. We can just say that angle DCA is going to be equal to 68.62 degrees. Then this last question says, what is the area of POSC? POSC. So at first I was looking at this question a little bit weird. I was trying to look somehow with this triangle over here, but that wasn't working out so nicely because we had this awkward little piece over here. But what I just realized is we could go work out this triangle's area. Okay. And then we would be able to work out this little triangle's area. And then just minus those two values. And then we will be left with the part in yellow that they are looking for. So step one, we go calculate the area of this triangle. Now remember, to calculate area, you either use half base times height, if you know the base and the perpendicular height, or you use half AB sin C. Now, we can use the half base height for this triangle, because you could, for example, take this as your base, and then your perpendicular height would just be from here to there. That is your perpendicular height, because those are going to be perpendicular. Remember that if a triangle is not 90 degrees, you can still use this formula as long as you can find the perpendicular. So for example, if you have a triangle like that, and let's say you use this as your base, let's say this is your base, then to find the perpendicular height, you always go to the opposite corner, which is this one, and then you draw a line 90 degrees to the base. So if you can find that length there, then that is your height. Even though this isn't a line, or even though this isn't a side in the triangle, it's still the height. So this height is going to be very easy because we're going perpendicular to the x-axis. So if you look at this y value here, it's -3. And if you had to imagine the y value here on the x-axis, it would be 0. The coordinates of that point would be -2, which is the same as this one. Same x value, but then the y value would be 0. So what would this vertical height be? Well, that vertical height would be 3 units because it goes from 0 to -3. Maybe that's confusing some of you. Let me just show you. If you have a point here on your x-axis, -2 and 0, and you have a point directly below that, it would be at -2 and -3, then this vertical distance must be 3 units. Because you're going from 0 to -3. So we're not going to make this a negative, we're just looking at how long it is. So it's just going to be 3 units, okay? So now we have the height. So we can just say that the area of triangle PFC is going to be a half base times height, which would be a half of PF. Now PF, Ooh, we haven't even looked at PF yet. Never mind, I've gone a little bit too soon there. So to work out the length of PF, we need to go and we would need to get the coordinates of P. Now remember, we did work out the equation. Remember, they asked us to work out the equation of this line CD. It was y equals to negative 3x minus 9. So to find the coordinates of P, that is the x-intercept of that line. So to find the x-intercept, you make y 0. So we could say 0 is equal to minus 3x minus 9, and then just solve for x, and you should get x equals to negative 3. So the coordinates then for P would be negative 3 and 0. Then to find the coordinates of F is on this line here, and we have the equation of that line, remember? So we can just make the y value 0. So we can make y 0. So then we could say 5x take away 6 times 0 equals 8, and so 5x is equal to 8. So if you divide, x would be 8 over 5. Oh, I didn't write that nicely. 8 over 5. So then the coordinates of F would be 8 over 5 and 0. So now we can just work out the distance between those two. You could use between P and F. You could use the distance formula, but you don't have to because it's horizontal. So if I write this as a decimal instead, it's 1.6. So if I look at the distance, I know that from here to here is 3 units because that's negative 3. And then from here to here, that's 1.6. And so if I just add those two numbers together, I should find that PF is 4.6 units. PF is 4.6 units. And then I know my height of my triangle is, 3 units. So then what I can do is I can go work out the area of triangle PCF, and I can say that that's half. Now the base, we're going to say 4.6, and the height is 3, and that'll give us 6.9 units squared. Okay, so now we have the area of this triangle. Now all that we need to go and do, because remember, the goal of the question is to find the area of this. So what we need to do next is go find the area of this triangle here. So what we're going to do now is we're going to find the area of this triangle over here. Well, that'll now be very easy to do because we know that it's a 90-degree triangle. It's a 90-degree triangle. We know this length. We know this length is 1.6 because we know F's coordinate is 1.60. And then we also know this length is 4 over 3 because we found S's coordinates earlier, and so that length would be 4 over 3. So the area of triangle OFS would be half the base times height. Whether you switch the base or height around, it doesn't really matter. And if we work this out, I'm going to leave it unrounded, so 16 over 15 units squared. And so to work out now the area of this entire, this piece over here, POSC, we're going to say that it's the area of the big triangle, which we said was PCF, minus triangle OFS. And so that's going to give us 6.9 minus 16 over 15. And that'll give us 5.83 units squared. With this question, there will be more questions coming up. So we've got 4.1, 2, and 3. And then we've got a 4.4 over here. In the diagram, M is the center of the circle and Pn is the diameter. KL is a tangent. First question, calculate the coordinates of P. Well, what you can do here is, you know that this is the diameter. You know that M is the center. So M is the midpoint from here to here. It's the midpoint. So you could use the midpoint formula. And so we know that the midpoint is already 3 and negative 5. Now we can just say that this is, let's say this is x and y. Let's call that point number 2. Let's call that point number 1. And so you would say 7 plus x over 2 and y plus minus 2 over 2. Okay, so the 3 must be the answer for this part. So we can then say 3 must be the answer for that part. And then the minus 5 must be the answer for that part. So the way that we solve this now is I'm going to take this 2 and multiply it over. So we're going to say 6 equals to 7 plus x. And then you can solve for x and you would end up with negative 1. And then for this one, you're going to take the 2 over, and so you end up with negative 10 equals to y. Now this part here just becomes a minus 2. I'm then going to take the minus 2 over to the other side, and so that'll become minus 10 plus 2 equals to y, and so y would be negative 8. So then the coordinates of P would have to be negative 1 and negative 8. This question says, determine the equation of the circle in this form of here. Okay, so we have the center, and then we need the radius. So we know that the radius is this distance over here. So we can go work out the distance between these 2 points. If you wanted to, you could even work out the distance between those two. Or what some learners do is they even work out the distance between P and N, and then you just half your answer. Okay, so I'm going to go work out the distance between, let's go MN. And so my distance formula goes like that. And I'll use this as my point number 1 and this is my point number 2. And so that's going to give us 7 take away 3 plus minus 2 take away minus 5. Then just go type that on the calculator and you should get a beautiful answer of 5. Okay, so now when we go fill in the formula, you're just going to go say x take away 3 plus y plus 5 equals to 25. Let me explain. So the x minus 3 is just because the center has an x coordinate of 3. The plus 5 is because this is a minus 5, and you know it's always opposite with circles. And then with the radius is 5, but you have to square it when you put it into the formula. Okay, a lot of people put 5 here. A lot of learners put 5 there, but it's the radius squared. Okay, and then this question says, find the equation of KL. So KL is this one for how many marks? Oh, 5 marks. Lovely. In the form of y equals to mx plus c. Very easy question, actually. What we should know is that when you have a radius or a diameter, and then you have a tangent, they always have a 90 degree. So we can say that the gradient of mn, which is this part here, multiply by the gradient of KL will give us negative 1. Why do I say that? Remember, when 2 lines are perpendicular, meaning that they hit at 90 degrees, then there is a special mathematical property that tells us if you multiply their gradients, it'll give you negative 1. So what we can go do quickly is work out the gradient of mn. So the gradient formula goes like this. And so I will use this as 0.2, that is 0.1. And so we could say negative 5 take away negative 2 over 3 take away, what is that x value? 7. And that'll give us negative 5 plus 2 is negative 3 over 3 minus 7 is negative 4. And that'll give us a positive 3 over 4 gradient. So now we know the gradient of mn. So we could say 3 over 4 multiplied by the gradient of KL should give us -1. So to then work out the gradient of KL, you could say -1 divided by 3 over 4, and it should give you -4 over 3. Remember, when two lines are perpendicular, their gradients, they are upside down. So if the 4 is at the bottom, now the 4 is at the top. And if this one's positive, then this one's negative. It's always like that. So we now have the gradient of the tangent, which is that one. So we can then say y equals to mx plus c, which then becomes y equals to -4 over 3x plus c. To find c, you need to sub in a point on that line that we're looking for, which is the tangent line. So we can plug in n's coordinates. So we could say -2 equals to -4 over 3 times 7 plus c. And so c would be 22 over 3. And so we could then say y equals to -4 over 3x plus 22 over 3. This next question, I see it got a little bit chopped off at the bottom here. So I'll just fill that in. It is a 3. Come on, why is my pen acting weird? That's a 3 over there. Whoops. Okay. So it says, for which values of k will this line be a secant to the circle? Well, let me explain what is a tangent, what is a secant, and then what is neither. So if you have a circle, okay, now a tangent touches exactly, it touches exactly like that. That is a tangent. If it doesn't go through, then it's called neither. Well, it's nothing. Let's just rather say it's nothing. If it goes through, then it's called a secant. Okay, now, we know from the previous question that this line has a gradient of -4 over 3, and here they're using -4 over 3 for the gradient again. So it's parallel lines that they're talking about here. So we could have a line that does that. Whoops, let's make it parallel. There we go. You could have a line that does that. You could have a line that does that. As long as they're all parallel. You see how they're all parallel to each other? They all have the same gradient. Whoopsie. Okay, let's draw another tangent. And then let's do another. So they want to know, because remember, by changing this k value on a straight line, that is the y-intercept. So if you make k very big, a very big positive number, then you're going to get lines going up here where they're going to intersect this y-axis at a very large number. If you make this very negative, then you're going to get lines going all the way down here where they have a very negative y-intercept. Okay? So they want to know, what must the k value be so that the lines will be circles? So that the lines will be secants. So the secants are going to be all of those ones. It's the ones that actually cut the circle. So what we will do is we need to look at the two tangents. There's a tangent over there, and then there's the tangent that we already looked at. So if we can, because those two tangents will give us the boundary limit. They will be the boundary of where that all happens. Okay, so we already know this one's equation. It's y equals to -4 over 3x plus 22 over 3. So the k value there is 22 over 3. Now we need to go find the, let's go find this line's equation. It will be very easy, because it's going to be parallel to this equation. So it's going to have the same gradient. And then you can just plug in the coordinates of p, which we already found is -1, -8. So we can just go plug that in quickly. Oops, there's a negative there. Okay, and so -8 would be +4 over 3. Now if you take the 4 over 3 to the other side, you end up with a c value as -28 over 3. So that means that this line's equation would then be y equals to -4 over 3x minus 28 over 3. So that would be the k value for this one. Now, if you increase this k value, well, then your y-intercept starts going up, and then you get this line, and then you go up some more, you get that line. If you go up some more, you're eventually going to get there, and then if you go up to 22.3, well, then your y-intercept would be about there. So we can choose, so if the k value is anywhere between this number and this number, then your line will be a secant, because it's within the boundaries of the tangents. Okay, it's a very good question, this. So we could say that the k can be any number bigger than, we're not going to say and equal to, because at that point it's a tangent. Okay, I'll show you interval notation now. And anything smaller than 22 over 3. If you would like to write it in interval notation, then you could say that k can be an element from negative 28 over 3 up to 22 over 3. Now, here's the last one for this question. So this is question 4.4 now. It says point A. Now, point A is not over here, but it says point A. Now, this part is critical that you understand. It says that it's got the same coordinates. There is a certain line that we've dealt with in grade 12 called the y equals x line. You know, the line that goes, woo, Kev, that was a bit skew, but it's the line that goes through the origin. And have you ever stopped to think about that line? It's called the y equals x line. It means that the y and the x values are the same at every moment. So for example, here, if the x value is 1, the y value is 1. Over here, if the x value is 2, the y value is 2. Over here, if the x value is minus 4, the y value is minus 4. So they are telling us that these two are the same. So point A is going to be somewhere along that y equals to x line that we've learnt about in grade 12 functions, inverses. So it says that point A, which we don't know, and B are not shown on the diagram. Okay? From point A, another tangent is drawn to touch the circle, which is the circle M, at B. Okay? So another tangent is drawn. So that could be, sure. So it says from point A, that could be in multiple places. You could, for example, have something like that, where point B is here and then A is on that line. Or you could have that, where B is there and A is on that line. As long as A is going to be somewhere on this line that I've showed you, and B will be the place where it touches the circle, and it must be a tangent. So it can't do this. You can't do that. That's not a tangent. A tangent has to just touch at one place. So, for example, like that, or like that. Okay? So we don't yet know where A and B is. We have no idea where A and B is, but I'm just showing you possibilities. From point A, a tangent is drawn to touch the circle at B. Show that the length of the tangent is given by that. Okay. So let's just, when this happens in mathematics, you just choose a scenario. So you're just going to call this point A, and you're going to give it the coordinates T and T. You're not going to say, yeah, but Kevin, isn't the X value negative over here and the Y value negative? Nope. You're just going to say T and T. If those coordinates end up having to be negative, mathematically, it'll work out. Okay? Then I want you to go ahead and, or let's put it over here rather. Let's put it there, for example. Otherwise, you're going to think it's parallel to this tangent. Then we're just going to go draw a tangent like that. So where it touches, that is the coordinates of B. Now they want us to find the length of that tangent. Well, that's very easy. What you do is the following. Because it seems tricky. I know that it seems tricky, but all you do is you make a triangle, because there to the center and then to there, whoops. Then you know that this is 90 degrees, because a tangent is always perpendicular to a radius line. So then what you do is they want you to find the length of AB. So you can just go use Pythagoras, because we already know this length. This length here is 5. It's the radius of the circle that we found in the earlier parts. Okay, we found that the radius was 5, remember? And then we could easily try, well, we could try to work out this length over here by using the distance formula. So that and that, we could use the distance formula. And then we could use Pythagoras to find that length. Don't know why it's 2 marks. It's a little bit more work than 2 marks, I would say. But anyways, let's go get the distance of MA. So MA, we use the distance formula. Okay, so I'll use point A as my number 2 and point M as my number 1. So we could say, now just use T. Just say T minus 3 plus T minus 5. And that'll give us T minus 3 squared plus T plus 5 squared. Great. Stop there. That's fine. There's nothing more you can do. Now, okay, so we've got this length and we've got this length. So Pythagoras, we are going to go and find this one. So we're going to have to minus. So we're going to say AB squared is equal to AM squared minus MB squared, right? Because this is point B. So I'm just using Pythagoras now. Remember, it's always the longest one, which is this line, minus the other one, if we're trying to find this. So check how easy this becomes, because now we can just do this. Now if you AM squared, so if you square this, then it gets rid of the square root, right? Because they just want the square. They don't want AM. They want AM squared. So if you had to square that, then it actually just gets rid of the square root. So there's AM, so we can just say T minus 3 squared plus T plus 5 squared. I know we're going to have to get AB by itself eventually, but I'm just saying the way Pythagoras works. We should say here Pythagoras. Okay, and then minus MB, which is 5 squared, which is just going to be 25. Okay, so now we're just going to go multiply all of this out quickly and simplify it. So that'll give us AB squared. Now, remember to put 2 brackets over here, but I'm just going to speed it up. So it'll be T squared minus 6T plus 9 plus T squared plus 9 on this part. This will give us 10T plus 25, and then this is minus 25. So these two would cancel. So we end up with AB squared is then going to be T squared plus T squared, which is 2T squared. And then minus 6T plus 10T would give us a positive 4T. And then a positive 9. And that's exact. And then to get AB alone, of course, we would take the square root. So AB would then be square root of 2T squared plus 4T plus 9. And there's what they wanted. That's also quite a good question. I don't know how they're doing it for 2 marks. I went and had a quick look on the memo because I was curious, and they actually did exactly what we did. So for 2 marks, that's a bit crazy. The next question for 4 marks, or the last question for 4 marks, it says determine the minimum. Well, if the length of AB is given by this expression, 2T squared plus 4T plus 9, then the minimum is when this stuff inside here is going to be as small as possible. So, because if you can make this number very small, the number inside here, if you can make that very small, well then the square root of that is also going to be small. So all you do is you just think about what type of graph is that. Well done. That's a if you said that that's a parabola. And because this number is positive, it's a happy parabola. Okay? So if we could try to find this point over here, this minimum value on that graph, then if you put that minimum value inside here, then this whole thing will be a minimum value, and so AB will be a minimum. So what I'm going to do is I'm just going to go take this expression, and I'm just going to try and make that expression. I'm going to try find the smallest or the lowest part of that expression, and that's the turning point. So I will use minus b over 2a, and so I will get minus 4 over 2 times 2, which is going to give me negative 1. That's not the answer. That just tells me the x value of this minimum value on this kind of graph. To find the actual value, I have to plug that minus 1 into this expression. And that'll give 2 minus 4 plus 9, which is going to be minus 2 plus 9, which is 7. So that is the lowest value that you could ever get in this expression. It's a 7. So then if you take the square root of 7, you get 2.65 units. That's a brilliant question. The first thing you're going to notice about this question is that I've blocked something off here. So before you start the question, just listen up carefully. That plus over there, that is actually going to be changed to a negative. Let me give you a story about this question. So this question became quite famous in 2022 when the matriculants wrote their final exam paper. This was the matric final exam paper 2. And this question, if it has a plus over here, actually does not make any sense. And, you know, the examiners, they were like, oh yeah, there's a mistake, so we'll just give these learners the marks for free. But that's not good enough in my opinion, because think about the amount of stress that it caused some learners who thought that they maybe knew their work, and then they get to a question like this, and suddenly they get completely thrown away. Or thrown off. Don't you think that that would knock their confidence a little bit, and they would start doubting themselves? Now, when you're in that panicked state where you don't feel so confident about your work, then when you move on to the next questions, don't you think that would have a slight impact? So I really think it's bad that they allowed this wrong question to go into an exam. These questions are supposed to be checked multiple times by different examiners, and to be honest, this is a very easy question to pick up that there's a mistake. I don't know how they let this one slip. Anyways, so what we're going to do to make this question actually work and make sense is we need to change that plus to a minus. So let me do that for us nicely. So, whoops, let's take that away. And let's take that away. Come on. I don't know why it's not working so nicely. Okay, I'll tell you what. Just turn it into a minus. Let's just block all of that off, to be honest. And then put it as a minus. Okay? Now the question makes sense. And this is probably what they were planning, or this is, yeah, maybe they made a little mistake with that, but now the question is absolutely fine. So let's go do this question now. So it says, given that this is equal to that, where that, without using a calculator, determine these things. Okay, so this is definitely one of those questions where you want to draw yourself the cast diagram, and then you want to see where it is on the cast diagram. So we start with this piece of information here, which says square root 13 sin x minus 3 equals 0. Then what you do is you get the sin x by itself, so you're going to end up with that over there. Then you're going to divide by square root 13. There we go. So that tells us that sin is equal to something that is positive. So sin is something that is positive. So sin can be positive in this quadrant and in this quadrant. Then they tell us that the quadrant must be between 90 and 270. So if this is 90 and this is 270, then that could be here or here. So we can see that both scenarios are satisfied over here, and so this is the quadrant that we will use. Okay? And so we're going to put that like that. We're going to draw a triangle, and then we're going to put the angle. What is the angle? X. We're going to put that over there. Right. Now they said that sin is equal to that over there. Now remember that sin is equal to the opposite over the hypotenuse. Some learners prefer y over r. So however you do that, you should get a 3 over here and a square root 13 over here. Then always look at this number. Should it be positive or negative? Well, it should be a positive because it's above the x-axis. Now, to find this part over here, we can use Pythagoras, and so we can say square root 13 squared minus 3 squared. And if we work that out, that'll give us 4, and then we have to take the square root of that, and that'll give us 2. So we'll put a 2 over here. But now remember that this 2 is a negative because it's on the left. It's a negative x. So you're going to put a negative 2 there. Okay. Now that our triangle is complete, now we can go and complete these questions. So the first one says sin 360 plus x. Now, remember, all that you need to do here is just take away 360. So you can just, you're always allowed to add or take away 360 if you want to, or if you need to, and so that'll just give us the sin of x. And so we already know the sin of x, it's going to be 3 over square root 13. Tan of x. Now you should know that tan is opposite over adjacent, or for the learners that prefer the XYR method, it would be y over x. And so that is going to give us opposite over adjacent, so that's going to be 3 over negative 2. If you type that on the calculator, it's just going to say negative 3 over 2. And then cos 180 plus x. Well, remember, on your cast diagram, this is the 180 minus x quadrant, this is the 180 plus x, and this is 360 minus x. So we have 180 plus x, which is this one over here, but cos is negative in that quadrant, so this just becomes negative cos x. And so that becomes negative. And then what is the cos of x? Well, to do that, you'd use this triangle. And so remember that cos is adjacent over hypotenuse, or x over r. And so now when we fill in x over r, or adjacent over hypotenuse, so the adjacent is negative 2, and then the hypotenuse is square root 13. So if you had to go work this out, it'll give you 2 over square root 13. Now, you've got to be careful here, because if you go type this on the calculator now, it will give you a different looking answer. It'll give you something that looks like this: 2 square root 13 over 13. Now, these two things are actually exactly the same, but calculators will never give you a square root in the denominator, because they do something called rationalizing the denominator. So they said without using a calculator. So sometimes they penalize you if you went from here to here, and sometimes they won't. So you got to be careful, but yeah, it's a bit tricky to know when they're going to penalize you and when they won't. But yeah, because I know a lot of you'll just type that on the calculator, but be careful when there's a square root in the denominator. Then it changes it to look different, but they're actually the same thing. Determine the following without using a calculator. Okay, so the first one is a cos 90 plus theta. Now you must identify that as one of the 4 co-functions that we know. So we know the following co-functions. We know sin 90 minus theta, sin 90 plus theta, cos 90 minus theta, and cos 90 plus theta. So this one becomes cos, this one becomes cos, this one becomes sin, and then this one becomes negative sin. That's the only one that's negative. So the one that we have, they gave us the tricky one. Okay, so it's that one over there. So we'll change that to a negative sin theta. Then over here, please, a lot of learners, they want to take out a negative as a common factor. You cannot take out negatives as common factors when you're busy with these trigonometry. When you've got that, you can't take it out the angle like that. You don't want to take it out the angle. So the rule that I've always told learners to do is to draw out your main quadrants. We've got 180 minus, 180 plus, and 360 minus. Here's the golden words. If it does not look like one of those 3, either add 360 or subtract 360. So if you look at this, don't think that it's the same as that. It is not even close. So what you rather do is, for this one, you will add 360. But Kevin, how can we just add and take away stuff? Because let's say, for example, that this, let's say it's over here for some reason. Now, if you add 360, you're still going to be at the same place. So mathematically, you have not changed it. So if you had to go simplify that now, that'll become theta plus 180. Now, when you plus, the order does not matter. For example, 3 plus 5 is 8, but 5 plus 3 is also 8. So when you plus, the order doesn't matter. So we can change this now to the sin of 180 plus theta, which is this one over here. So now that we have one of these, we good. Because now, so let's just go fill that in here. I should have done it over here. Plus 360. Okay, and then that became negative sin theta over the sin of, let's just change it now to 180 plus theta. That's fine. Plus 3 sin negative theta. Now, that is this one, but sin is negative in that quadrant. So we're just going to do this now. Becomes negative sin theta plus. Now, a lot of learners, they'll try cancel that. You cannot cancel that because there's more than one term at the bottom here. Okay, so you cannot cancel. So now what do we do here? So a lot of learners, they say, oh, I'll just take the negative out as a common factor. Once again, not correct. You never want to take a negative out of the angle. You cannot. It's not, maybe you'll get the right answer, but it's for the wrong reason, and teachers will pick up on that. So use my golden rule. If this does not look like any one of these, either add or subtract 360. So we will add 360 to that one. So it's going to become, whoops, like that. Then when you add, the order doesn't matter. So we can switch this around to become 360 minus theta, which is this one. There we go. And then I'm just going to carry on over here. So it's negative sin theta. And now negative sin theta. Now this is, or this part here, sorry. Sin is negative in that quadrant. So it's going to become negative 3 sin theta. Now some of you would have got that same answer if you took out a negative as a common factor, but it's a coincidence. And teachers can pick up on that. So be careful with that, please. Okay, so now I'm just going to carry on with this over here. So at the top, we're just going to have negative sin theta. At the bottom, you're just going to put these together. It's like saying minus 1 sin theta minus 3 sin theta. Well, that'll just give us minus 4 sin theta. Now you can cancel these. Why? Because you have one term at the top, one term at the bottom. But over here, you had one term at the top, but two terms at the bottom. So you can only cancel when you have a one term and a one term. That's it. So the negatives cancel. Let's cancel them out. Or let's actually do that on the next line. And then the sins cancel. So you just cancel the negative and the sin. And so you just left with a 4 at the bottom. And then if there's nothing at the top, you can just put it as a 1. Determine the general solution. Now, before you get tempted to just go multiply these brackets together, be careful. Brackets are good, especially when you have a 0 here. For example, if you have x minus 4, x plus 1 equals to 0, you wouldn't multiply that out. You'll just say x minus 4 is equal to 0 or x plus 1 is equal to 0. And then you would solve each one individually. So we're going to do the same thing over here. We're going to say cos x plus 2 sin x equals to 0. Or 3 sin 2x minus 1 equals to 0. Now, those are going to become two brand new questions. So you need to know the different types of general solutions that I've showed you. You should identify that this one is going to become a tan. The way that you make it a tan is you're going to take the cos x over to the other side. Then you're going to divide both sides by cos x. So you're going to divide this by cos x. Well, what we're doing is we're dividing this cos x over to the left-hand side. So we're going to end up with like that. And then we're dividing this side by cos x as well. And so here it cancels out. So you just end up with minus 1 over here. And then sin over cos becomes tan. So we have 2 tan x equals to negative 1. And then just get that 2 away. So tan x is equal to negative 1 over 2. And then we can go solve that one using general solution. So to get your reference angle, you would say shift tan of a half. You don't put the negative. So you would say, it would look like this on your calculator, of a half. And that'll give us 26 point, now it's best to keep the decimals, 5650518 Okay, so that's it. And then, okay, now they're saying tan here is negative. So let's just quickly write this out. So if you have 180 minus x, 180 plus x, 360 minus x, we know tan is negative in this quadrant and this quadrant. Now remember, with tan, you only have to choose one quadrant. If you choose both, it's not wrong. It's just a waste of your time. So I'm going to choose this one. So we're going to say x, because there's an x over there. If there was a 2x, then I'd say 2x. But it says x equals, then I'm going to say 180 minus, then it's this reference angle number. And then we're going to say plus k times 180. K is an element of z. Then if we work that out and round our answer to 2 decimal places, we get 153.43 plus k180. K is an element of z. Now we can move on to this second part. Now, what I'm going to do with this one is this is actually a very easy one. I know a lot of you watching this are grade 11 and some of you are grade 12. Now, for the grade 12s, I know you're looking at this and you're like, oh, a double angle, but you don't have to. In fact, I wouldn't do that at all. What I would rather do is just keep it really easy, literally like grade 10 kind of trigonometry. Check this out. You can just do that. And now that you've got this part by itself, you can go get your reference angle. So you can say reference angle is equal to shift sin, so it'll look like that on your calculator, of a third, and that'll give you 19.47 and then 122.063. Now that's just your reference angle. So some learners, they'll say 2x over here. Now leave it there. What a lot of learners then go do is they go get x by itself. You don't want to do that. You want to keep it as the same angle that you have over there. Okay? Now they're telling us that sin is a positive number. So we know that sin is positive in the first two quadrants. Now, for sin and cos, we have to show both quadrants. So for quadrant 1, we will say, now we won't say x equals, you will say 2x equals. It's always whatever your angle is, that's what you put over there. That's why for this one I just used an x, because there was only an x over there. So 19.47, that number, plus k times 360, KEZ. I can't remember if I mentioned it here, but remember tan is always 180. And then we're now going to get, if we go divide everything by 2, we end up with 9.74 plus k times 180, KEZ. Then for quadrant number 2, we can say 2x equals to 180 minus, because that's what quadrant 2 says. It's 180 minus the reference angle number, that whole number, plus k times 360. K is an element of z. And then you're going to go ahead, simplify, and you would eventually end up with 80.26 plus k times 180. K is an element of z. Given the identity, prove the identity. Okay, so the first question, the thing we need to do is prove. Okay, so this one looks quite interesting. So we've got cos. Well, let's actually just choose a side that we're going to work on. I think we can start working on this side over here. Okay, so cos, so we should say left hand side. And so we have cos x plus y, cos x minus y. So immediately I'm thinking of our compound angles. These ones over here. So we've got a cos x plus y, so that's the same as this one. So I'm going to expand it, so that's going to become cos x cos y minus sin x sin y. Okay, put a bracket. And then we've got this one, which is this one over here. So we're going to expand that as cos x cos y, and then it becomes a plus sin x sin y. Now what we're going to do is we can multiply all of this together. So we're going to multiply this term and this term together. So that'll become cos squared x cos squared y. then we're going to multiply those parts together, and then you'd multiply those parts together. And what you'll find is that this part and then this part, the one will be a plus and the one will be a minus, and so those parts will actually cancel out. And then lastly, we will be left with this last part. So that'll become minus sin squared x, sin squared y. What I would then do is I'd look at I would look at this part over here, and I'd realize that there's only sin. So I need to get rid of these two. The way that I'll do that is by using a grade 11 identity, which is sin squared x plus cos squared x equals to 1. And if I get cos squared x by itself, it'll give me 1 minus sin squared x. So I'm going to replace this one and this one. So this will be 1 minus sin squared x. This one will be 1 minus sin squared y. And then we've got this and this. What I'll do now is just multiply these two brackets together. And so that'll become 1 minus sin squared y minus sin squared x. And then when you multiply these two together, it becomes plus sin squared x, sin squared y. Then we still have this part here, which is minus sin squared x, sin squared y. So these parts here cancel, and then we are left with 1 minus sin squared y minus sin squared x, which is what we have here. And so we can then say, therefore, left-hand side is the same as the right-hand side. Okay, so we've done that. Then it says, hence, determine the value of this. Okay, so can you see that this copies that? All that they're saying there is that x is 45 and y is 15. Can you see that then they're the same? So the way that these hence questions work is that you're going to use the previous information. So what I'm going to do is, you see how we saw that this is the same as that, but we know now that this is equal to that. So we're actually going to use this one. So we're going to use cos x plus y, cos x minus y. And so x is 45 and y is 15. That then becomes cos 60 and cos 30. So we know that these are special angles. So we've got our special triangles. I'm only going to do the 30-60 one. 30-60. 1, 2, square root 3. And so now we can go work out the cos of 60. Cos is adjacent over hypotenuse. So adjacent over hypotenuse, that's a half. And then the cos of 30, adjacent over hypotenuse. So that would be the square root 3 over 2. And that's going to give us square root 3 over 4. Consider the trigonometric expression, and then they give us this ugly looking thing. Rewrite this expression as a single ratio. Okay, so 16 sin x cos cubed x minus 8 sin x cos x. Step 1, I'm going to take out a common factor. The common factor of these two numbers is the number 8, so I can take that out. Then I see that this one has a sin and this one has a sin, so I can take that out of both. And then I see this one has cos 3x, so that means it's got 3 coses, and this one's got 1 cos, so I could at least take out 1 cos. Now, to see what's left, there will be a 2 over here, because 8 times 2 is 16. There will be no sin x's left, and there will be 2 coses left, so it will look like that. Then I'm going to say minus. Then the 8 and the sin x, that'll be gone, because we've got it over there. And then actually all of this will be gone. See? So we're just going to say minus 1 over here. I know a lot of you struggle with what I just did there. So let me show you in a different way. You could imagine that 16 sin x cos 3x is the same as cos x, cos x, cos x. That is what cos 3x is, okay? And then we could say minus 8 sin x cos x. So what I did is I took out an 8. I then took out a sin because there's a sin in both. And then I realized there was also a cos in both. Then when I did this part, I knew that I would need to put a 2. The sin is already gone, but then I saw that there's still 2 coses left over. So I did that, and that's how I got that part over there. Okay, and then of course this part was minus 1. Now, this part here should look familiar to you. You see, if you look over here, can you see it? So what we'll do is we will condense or change this to that. So we're going to end up with 8 sin x cos x, and then that part there becomes cos of 2x. Now, technically this is it's not a single trig ratio. They want it as a single, I thought they said single term. So they only want sin or cos. So what you should realize now is that this is actually also something quite interesting. If I do this, if I change it from 8 to 4 multiplied by 2, because that's still 8. Now look at this part. You see, so it's this part here that we have. So we're going to change it to that. So it's going to become sin 2x cos 2x. And now, if I change this 4 to a 2 times 2, then here we have that, which is the same as this. But remember now, the angle over here is alpha and alpha. Here, it's 2x and 2x. So what happens is that the alpha becomes 2 alpha. So the 2x will become 4x. So now we're going to end up with 2 because of that 2 over there. Nothing happens to that one. And then this part here becomes sin 4x. And that is a single trig ratio. This question says, for which value of x over the following interval will this ugly expression, which obviously we're going to just change it to this beautiful expression, have its minimum value? Okay, so obviously in an exam, you'll just tell them that 16 sin x cos 3x minus 8 sin x cos x. We will change that to 2 sin 4x. Okay, so now we're just going to look at 2 sin 4x, and we want to find its minimum. Now, we know, and they only want us to look between 0 and 90. So we know that on a sin graph, it does this. So where would it have its minimum? Oh, but they only want us to go up to 90, so that's literally there. So where is the minimum? Well, the minimum is when the angle is 0 degrees. So we would like the angle to be 0 degrees, so we're going to make that equal to 0. And then if you solve for x, you would end up with 0. And that's the answer. So if you were to go and think about what this graph looks like. So we know that a normal sin graph has a period of 360. That means that it completes a cycle, one cycle, in 360 degrees. But that's a normal sin graph, sin x. But when there's a number over here, you can see the new period by saying original period divided by this number, which I often call that k. Okay? And so, you know, I've showed this in some videos where you've got sin of k x minus p plus q. That number there is what helps us determine the period. So if we can now say that the period is going to be the original period, which is 360, divided by 4, that'll give us 90. That means that this graph is now going to complete in 90 degrees. So 90 degrees. That means this will be 45, this will be 22.5, and this will be 67.5. So where do we see the minimum? Well, the minimum is going to be down here. So it's when the angle x is 67.5. So we will say 67.5. With this question, there will be more coming up over there. So we've got these three and then those two. So it says, in the diagram below, the graphs of f, which is a tan graph, and, okay, let's highlight. So f is a tan graph. So there, just a normal tan graph. And then g of x is a sin graph, so like that. Now the first question for 1 mark says, what is the period of g? The period is how long does a graph take to make one cycle. So you can see that it starts of a year and it completes one cycle there at 180 degrees. So that'll be the period. Another way to work out the period is to take the original period of that graph. We know that the original sin graph has a period of 360 for sin and cos. For tan, it's 180. And then you divide it by k. Now, what do I mean by k? It's this number in front of the x. You know how I sometimes show y equals to a sin of k, x minus p plus q? Well, that k is what I'm talking about. So the original is 360. The k value they've told us here is a 2, and that'll give us 180. Okay, this one says, calculate the value of k. Okay, which k are they talking about? Oh, they're talking about this k, I see. So the point A is... Oh, it says point A and B are 2 points of intersection. Oh, okay, so it's on both graphs. So this is a very easy question, because you know the x value, but you just need the y value. So you can just plug it into the equation. So f of 60, so you're just letting x equal to 60. Go ahead, type that on your calculator, and you get square root 3. You could have also used this equation, absolutely fine, and so that will just give us square root 3. And of course you could also write it in decimals. If you do it in decimals, it'll be 1.73. The next one, calculate the coordinates of B. Where is B? Okay, B is where these graphs are intersecting, but it's only for 1 mark, so you don't need to go do some crazy simultaneous equations and all of that. Just remember that graph G has a period of 180. That means that it takes 180 degrees to get from this position to this position. Can you see that they are equal? Look at that. Or what I'm trying to say is, sorry, can you see that on graph G, which is the sin graph, it'll take 180 degrees to repeat itself. So it would take 180 degrees to go from there to there, for example. It would take 180 degrees to go from there to there, and it would take 180 degrees to go from there to there. All of the places that are the same, it takes 180 degrees to go between those places. So it's 180 degrees to go between A and B. So if this is 60 degrees, if you minus 180, that'll give you negative 120. And the y value is on the same horizontal as that one. And so that would be, I mean, it's difficult to say that it's the same, but for 1 mark, you would just make that assumption. So it's going to be like that. This question says, write down the range of g of x, but if they put a 2 in the front. Okay, so let's ignore the 2 in the front. Let's just look at g of x for now. So g of x is the sin graph. Okay, so its range at the moment goes from, okay, they haven't given us numbers, but you should know that this 2 in the front here makes the graph go up to 2 and down to negative 2. Okay, but now if they put a 2 in the front, then that'll multiply the graph by 2. So it'll actually go up to, it'll go all the way up to 4. Whoops. Let's do that again. And down to negative 4. So 4 and then down to negative 4. So the range will now be, you could say y is an element going from negative 4 to positive 4. If you prefer interval notation, you could say y is bigger than or equal to negative 4, smaller than or equal to 4. Carrying on, these questions say, for which value of x will this ugly expression be smaller than 0 in the interval minus 90 to 0? Okay, so they only want us to look between this area over here. So they want to know, okay, well this isn't nice to work with, so what you rather do is you just do this. You take the f graph to the other side, and then you have that. So they're saying, where is the graph of g? And then don't worry about the x plus 5, we'll talk about that now. Where is the graph of g smaller than the graph of f? Is this green one over here. And then the graph of f is that one. Now it says, where is the graph of g smaller than f? And then we'll talk about the x plus 5 just now. So where is the green graph underneath the yellow graph? Well, that's going to be from here up to here. That's where the green is underneath. So as I said, we will come back to the x plus 5 part. So it's going to be from this coordinate to that coordinate. So luckily we know that coordinate, it's 0, but we don't have this coordinate. But now can you see that you can see there's like a symmetry from here to here, right? That distance, that horizontal, or that to there and to there is the same. So if we know that this is 60 degrees, then this one here should be negative 60. Okay, so that's negative 60. Okay, so we're going from negative 60 to 0. But now we have to look at this x plus 5. They're doing it to both of the graphs. Now, what does x plus 5 do? Well, x plus 5 moves the graph 5 degrees to the left. 5 degrees left. But it's moving both of these graphs 5 degrees to the left. So this is just going to go to negative 65, and this is going to go to negative 5. So we could just say x must be they have equal to as well. Okay, negative 65 and smaller than negative 5. If you prefer interval notation, you could go from negative 65 up to negative 5. Now, some of you might be like, yeah, but Kevin, if we move it 5 degrees to the left, doesn't it change where they intersect? It won't change where they intersect because we're moving both of the graphs to the left. So that won't change anything. This last one says, for 3 marks, determine the values of p for which sin x cos x, okay, sin x cos x is equal to p, will have exactly 2 real roots in the interval. Now, if you read that question and you just like, I don't understand a thing, then you can leave that question out in the exam. If you're a student that is getting in the 40s, 50s, 60s, even the 70s, you don't have to attempt every single question. If you see a question like this that's got these ugly words like roots and blah, 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 leave it out. I'm not saying leave out all questions, but especially these last kind of questions in a question like this. Because you got to weigh up how long is it going to take you. And if it takes you too long, then you are going to decrease your chances of being able to do the questions after this if it was an exam successfully. That's the problem that we have. If it's 3 marks, you don't want to spend too much time on it. Remember, these exams are 3 hours long, so you have 180 minutes, and they're out of 150 marks if it's a full exam paper. So if you divide those two numbers, you get 1.2 minutes per mark. 1.2 minutes per mark. So if you say 1.2 minutes per mark multiplied by 3, that's 3.6. That means 3 minutes and 36 seconds. 3 minutes and 36 seconds. So if this question takes you longer than 3 minutes and 36 seconds, move on. Like if you're going to sit and do this question for 10 minutes, that's really hurting your ability to do your other questions. Okay, but what we can do is, let's try this question. So it says, let's just work on this quickly. I can see here there's a sin 2x. Now we know that that is a double angle. Well, it could be a double angle. So what I'm going to do is I'm going to start working on this a little bit. So I'm going to say g of x is equal to 2 sin of 2x. Then I'm going to say g of x is equal to 2, and then I'm going to change the sin 2x into this. So that's going to be 2 sin x cos x, and then that's going to be g of x is equal to 2 times 2 is 4 sin x cos x. And then what I'm going to then do is take this expression, sin x cos x equals to p, and I'm going to multiply both sides by 4. Okay, because in maths you're allowed to do that. If you do it to the one side, you do it to the other side. So now, all of a sudden, the question is very different. They are now saying that g of x, which is that, so they're saying, where does the graph of g of x have exactly 2 real roots? Well, remember, these are like y values. So let's say the y value is 1. So the y value of 1 is somewhere here. So if you draw a horizontal line where y is 1, it'll cut the graph 1, 2, 3, 4 times. But they want to know, where does it only cut? Twice. They want only 2 roots. Okay? So maybe if we make y equal to 2, that works perfectly, because have a look there, it only cuts twice. And if you make y equal to minus 2, it also only cuts twice. And so there's where our 2 answers should be. So the y value, or this graph, it's wherever this graph is equal to 2 or negative 2. So we could then say that the 4p must be equal to 2, or the 4p must be negative 2. And so if you then solve, you'd end up with p equals to 1/2 or p equals to negative 1/2. That's quite a weird question. AB is a vertical flagpole, okay, that is square root 5p meters long. AC and AD are 2 cables anchoring the flagpole. BC and D are on the horizontal plane. BD is 2p. Okay, so everything they've told us is on the diagram. And there we go. So the first question for 2 marks. Determine the length of AD in terms of P. AD, where you AD? There you are. In terms of P. Okay, so don't use this angle. A lot of learners are going to use that angle, but that angle is not part of that triangle. That angle is part of this triangle. And that's not the triangle we are going to be working in right now. Okay? We are going to work in this triangle right now. That is a 90-degree triangle, and we already have 2 of the sides. So we can literally just go use Pythagoras to find AD. So we could say that AD squared is equal to BD squared plus AB squared, and that will just be Pythagoras. So we could say AD squared is then equal to BD, which is 2p, remember to put it in a bracket, square, plus AB, which is square root 5p squared, and that's going to give us 4p squared plus, now this, when you square it, just becomes a 5, and this, when you square it, just becomes p squared. And so AD squared is then going to be 9p squared, and then I'm going to square root both sides and end up with 3p. Yeah, you could say plus minus, but when it's distances, we don't put the minus part, so we're just going to say 3p. Next one for 5 marks. Looks beautiful. That was sarcasm. Show that the length of CD is equal to that. All right. So now what we have is we know that this is 3p. I definitely think that we can work in this triangle. And we know this angle. See, this angle is part of this yellow triangle that I've highlighted. and we've got this angle over here. So we could use the sin rule. We could say this. We could use those two, the angle and the side. And then we could use this angle. We could go calculate it, and then we could find CD. So our first step is just to go find this angle. So to do that, we will just say that angle CAD is 180 minus x minus 45, and that's just going to be sum of angles in a triangle. And so angle CAD would then be equal to 135 minus x. So this angle here is 135 minus x. Now we can use the sin rule, which says A over sin A equals B over sin B. So it's all about opposites. So for example, we could take this one over this one, and then this side over this angle. So that's going to be 3p over the sin of x equals to, and look, I'm not even worried about what this says right now. I know that it'll get there later on. I'm just trying to do mathematics right now. And then that's going to be CD over the sin of 135 take away x. Okay, what I'm going to do now is try get CD by itself. The way that I do that is I just multiply this up to the top over there. So we're going to end up with an expression now that says CD, you would eventually get CD is equal to 3p sin of 135 minus x over sin x. Okay, now what I think we can do here is we could use a compound angle for this part, specifically this one over here. So let's just put this 3p here. So we could say 3p, and then in brackets, I still don't know how this is going to work, but let's keep going. It's going to become sin 135 cos x minus cos 135 sin x. Okay, and then that's all over sin x. Now, sin 135 and cos 35, we will have to reduce those. So that's going to become 3p. And then sin 135 can become sin 180 minus 45. So that's just going to become sin 45 cos x. Now cos 135 is going to become negative cos 45. So that'll actually end up becoming plus. And then sin x over there. Let me just explain. Cos 135 is the same as cos 180 minus 45, but when you reduce, cos is negative in the 180 minus quadrant, so I just changed it to negative cos 45, and then at the bottom we have sin x. Okay, I think this is actually going to start working now. I can see where the square root 2's are coming from. Okay, so we're going to now say that that becomes 3p. Now sin 45 is 1 over square root 2. If you get square root 2 over 2, same thing. That's just because you're doing it on your calculator. I'm just using special triangles. Cos 45 exactly the same. And then sin x. Oh yeah, this is working. Over sin x. Okay, what we're going to do now is we're going to take out 1 over square root 2 as a common factor. So that's going to give us 3p over square root 2. You could also say 3p multiplied by 1 over square root 2, but I'm just going to write it as 3p over square root 2, and then you'd be left with cos x plus sin x, and then at the bottom you're left with sin x, and then mathematically you can just put the square root 2 down at the bottom. And then we've proved that works over there. So, okay, so you see what we actually did. We just went and did normal mathematics, and eventually it does lead us to that over there. That's quite a challenging one. This last one for 3 marks. If it is further given that P is 10 and X is 110 degrees, calculate the area of triangle ADC. Okay, so the area of triangle ADC. Where are you, ADC? Oh, there. Okay. Okay, this one will actually be pretty straightforward because we now know that to be able to find area of a triangle that doesn't have, like, we don't have the perpendicular height, then we just use half AB sin of C. And the way that formula works is that if you have a triangle and you have an angle, then you have to use the two sides. Next to that angle. So we know, determine the length of, okay, well, we've got this length as 3p, but then we also have the length of CD. We also have that one's length. So we could use this angle, and then, so this angle, and then these two sides. Okay? And so that's going to be half. Then you're going to use the two sides. The one is 3p, and the other one is this expression over here. So that's going to be 3p sin x plus cos x over square root 2 sin x. And then sin, because of this part, of the angle that we're using between them, which is 45. Okay, now they've told us that p is 10 and x is 110. So we can go fill that all in now. So half 3 times 10. Yeah, 3 times 10. Another 3 times 10. And then sin of 110 plus cos of 110 times sin of 45, and then that is going to be over square root 2 sin of 110. Then for 3 marks, you could literally just go type that all on the calculator right now, and that should eventually give us 143.11. And have they told us if it's in meters or yeah, meters. Okay, so we could just say meters squared. In the diagram, O is the center of the circle. MNPR is a cyclic quad. Yep, that makes sense because it's touching the circle in 4 places. Okay, so that's a cyclic quad. Quadrilateral, cyclic quad, sorry, and SN is a diameter. Chord MS and radius OR are drawn, and angle M2 is 64. Excellent. First question. Determine with reasons the size of angle P. Okay, so if you have a cyclic quad, then we should know that the opposite angles of a cyclic quad are supplementary, so they add up to 180. So we could say that angle P is going to be 180 minus 64, and that is because of opposite angles cyclic, whoops, I always get this word weird, cyclic quad. And so angle P is going to be 116 degrees. Next one asks us for angle M1. Angle M1, where are you? Over here. Okay, let's just put 116 over there. So with this one, oh no, let's leave that there. We know that this is a diameter. And so this angle up at the top here would have to be 90. Remember, whenever it's the diameter, then we use angles in a semicircle. So we could say that angle M1 is just going to be 90, take away 64, and that'll be because of angle, yep, in semicircle, and that'll give us 26 degrees. The last one asks us for angle O1. Now, can you see the bow tie over there? But it's not a normal bow tie where you've got both of these parts on the circumference. Can we see that one of them is at the center and the other one is on the circumference? So let's talk about that a little bit. So if you had a normal bow tie like this, where both of these angles are on the circumference of the circle, then those two angles are the same. That's where we say angles in the same segment. But if you have one of them on the edge, let's see if I can draw this nicely. where one of them is on the edge and one of them is at the center, then this is where the center is going to be double the circumference. Remember, angle at center equals 2 times angle at circumference. So if we know that this is 26 degrees, then angle O1 is going to be 2 times 26, which is 52, and that's going to be angle at center equals 2 times angle at circumference. In the diagram, triangle ABG is drawn, okay, obviously. D and E are the midpoints, so D and E are the midpoints. Okay, so we've got all that. Okay, so it says for 1 mark, give a reason why DE is parallel to BH. DE is parallel to BH. Well, that would be the midpoint theorem from grade 10. Remember in grade 10 we learnt about if you have a triangle with this part here being a midpoint and this side also being a midpoint, then automatically these were parallel. So you're literally just going to say here, midpoint theorem. This one for 6 marks. Lovely. Oh, and another thing with the midpoint theorem, I'm not sure if we're going to have to use it, but remember that it also means that this is half of this length. So this length here is double the length of that one. I'm not sure if we'll need that. If it is further given that FC over BF, so FC over BF is 1 over 4, so what we'll do, so I'm going to use 4y and 1y. I'm not going to use x because they've already got x over here. They then tell us that DE is 3x minus 1 and GH is x plus 1. Okay, so we are going to have to use the midpoint theorem property that I spoke about now. And so they say calculate giving reasons the value of x. Okay, so I'm going to go straight to BG is going to be 2 times the length of DE, and that's just because of midpoint theorem. So BG is then going to be 2 times 3x minus 1, which is going to give us 6x minus 2. 6x minus 2. Then what we're going to do is just do a bit of proportionality theorem, where we could say, for example, BG over GH is the same as BF over FC, and that's just going to be prop theorem. The reason is GF is parallel to HC. Now we can just go fill in 6x minus 2 over x plus 1 equals to 4y over 1y. Now notice that these y's cancel, and so then we just end up with 6x minus 2 over x plus 1 equals to 4 over 1. Then if we cross multiply, so you can multiply this up there and you multiply that up there, you end up with 6x minus 2 equals to 4 bracket x plus 1. And then that will be 6x minus 2 equals to 4x plus 4. Solve, 2x will be 6, therefore x will be 3. In the diagram, O is the center of the circle. OD bisects the chord. Prove the theorem that states that the line from the center of a circle that bisects a chord is perpendicular. Okay, so you know the theorem that says if you have a line from the center that causes this and this to be the same, then it means this is 90 degrees. They want us to prove that. This one's actually very easy. Let me explain it first and then I'll show you how to write it down. All we're going to do is just do a construction to there and to there. We're then going to show that these two triangles are congruent, meaning that they are exactly the same. And you know why? Because this line is the same as this line, so that's already one side. These lengths are equal because they are the radius of the circle. So they are the same. And then they both share this line over here, so that will be the same for both. So those two triangles are exactly the same. So that means this angle and this angle have to be exactly the same. But these two angles must also add up to 180 because they are on a straight line. So the only angles that they could be would be 90 and 90. Now let's go see how we would actually write that down in an exam. So we will say, construct AO and OB. Okay, so we go and construct, boom, 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 boom. Okay, so now in triangle AOD and triangle ODB, we could say that AD is the same as BD. That they've already given to us, these two, right? Then we could go and say that AO is the same as OB, and that's because they are the radii. And then we could say that OD is shared with OD, and that's because they are common. So therefore, triangle AOD must be congruent. Now make sure you get the order correct here. BOD. And the reason is side, side, side. So because those two triangles are the same, we could say these two angles must be the same. So therefore, angle ADO must be the same as angle ODB. And then you can just say therefore. Or we can be more specific. We could say angle ADO plus angle ODB must be 180 because of angles on a straight line. And so therefore ADO, which is the same as ODB, would have to be 90. So therefore OD is perpendicular to AB. In the diagram, EB, FS, and P are points on the circle centered at O. GB is a tangent. GB is a tangent. FE is produced to meet the tangent at G. OT is drawn such that T is the midpoint. Okay, so T is the midpoint over there. Okay. GO and BO are drawn, BS is drawn, and then those lines are parallel. Okay. Prove for 5 marks, giving reasons that OTBG is a cyclic quad. So OTBG is a cyclic quad. Remember, there are 3 ways to prove something is a cyclic quad. The first way is if the opposite angles, so if X and Y add up to 180, then it's a cyclic quad. Number 2, if you have the angle on the outside, let's call that X, then that would have to be the same as this one. So these two would have to be the same. We call that the exterior angle. And then number 3, if you can construct your cyclic quad, or if you could have some bow tie in your cyclic quad and you can find that those two angles are the same, like a bow tie, then it's also a cyclic quad. Okay, so one of the things we can see is that we know that this is a radius. This line over here is a radius, and we know that this is a tangent. Now, a radius and a tangent always make 90 degrees. So we could say, but now be careful, it's not this whole angle up to this line. It's only up to that line, okay? So it's up to there. So that is going to be called angle GBO. And that's going to be 90 degrees. And that's because of tangent, or tan, perpendicular to radius. The next thing is that if you look at this line, we've got a midpoint over here. And we've got a line coming from the center. Now we know that if you have a chord and you have a line coming from the center, if it divides that chord into 2 equal halves, then this automatically becomes 90 degrees. So this angle here, or you can actually rather say that one there, is 90 degrees. So that's going to be angle GTO. That's going to be 90 degrees. And that's because we have a line from the center to the midpoint of the chord. Some learners say, Kevin, isn't a line from center perpendicular to chord? No, that's the other way around. So what did we have already? We had the midpoint, and that is the reason why this is 90 degrees. So we put the midpoint part over there. If instead they gave us a 90, if they gave us a 90, oh, it's an ugly 90, but they didn't give us that, then you would say line from center perpendicular to chord. Okay, so we now have that as 90. Now remember I told you that there's 3 ways for something to be a cyclic quad. Option number 3 was when I said you might have something like, whoops, not like that. You might have something like this where you've got these angles being the same. Now, what's interesting is if you look at this angle, it is being produced by this chord. Because if you take this part and you take this part and you join them together, it creates that angle. But now that same chord, if you take it that way and that way, is also creating this angle. So both of those angles originate from this chord. So that is what we call angles in the same segment. Now that is actually happening here, and it actually took me a long time to figure that one out. So check this out. If you look at this chord, now if you go this way, if you go this way, you see how it comes together at this angle. And then if you go this way, that way, you see how it comes together at that angle. So we've got one chord that is creating 2 equal angles. So this is angle in the same segment. So then that means this shape must be a cyclic quad. So we can say here that angle GBO is equal to angle GTO. Okay, whoops, over there. And so we can say, therefore, the shape OTBG is cyclic quad, is a cyclic quad. And that is because converse angles in same segment. That was quite a tricky one. I took a while to get that one. Okay, this question for 4 marks says prove that, okay, well keep in mind now that this is a cyclic quad. They often like to, now that we know it's a cyclic quad, they like to test you on that going forward. So it says prove that angle GOB, where are you, GOB? Oh, GOB. Okay, so that's this angle. Prove that that is the same as this angle. Okay, so they want us to prove that these two are the same. Okay, well, I'm going to go straight back to that cyclic quad. And I know that if I start here and I work my way backwards to there, then I can say that this chord created that angle. Okay? So then, because it's a cyclic quad, I will look and see what other chords does this one create. So I'll take my pen or my finger and go that way to the edge of the cyclic quad, which is there, and I'll go to there. So that means this little angle here, this angle ETB, is the same as this angle. Let's just say here 9.2.2. So we could say that angle T, or no, not T, you have to say ETB. ETB is the same as angle GOB, and that's because of angles in same segment. Okay, so we now know that this angle here is the same as this, and then we can just use parallel lines. Let me try to show you. We've got parallel lines here, so we can use corresponding angles to say that this angle is the same as this angle. So we can say here that angle BT, or ETB again, let's just call it ETB, ETB is equal to angle S, and that's because of corresponding angles, because the line GF is parallel to PS. So then, therefore, GOB must be the same as S. GOB is the same as angle S. In the diagram, PQRS is cyclic quad, KP is a tangent, okay, that's a tangent. C and D are points on the chords, and CA is parallel, and then P1 is equal to R2. P1 is equal to R2. Okay, so they are equal. So this one is quite weird. So we want to prove that S1 is the same as T2. So S1 is the same as T2. Okay, so, the first thing I'm going to do, let's see. Oh yes, they did tell us that those two angles are equal. Okay, so they are equal. I'm going to use a tan chord over here. So if you look at that chord, it goes there and there. So that means Q1 is the same as P1. So P1 is the same as Q1, and that's because of Tangent-Chord Theorem. The next thing I notice is that, remember, this is a cyclic quad. And we know that if something is a cyclic quad, the exterior angle is the same as the opposite interior angle. So S1 will have to be the same as this whole angle. Okay, so S1 is the same as Q1 plus Q2. Now check this out. We know that Q1 is the same as P1, and P1 is the same as R2 because of that. So remember, we know that Q1 is the same as P1. And what did we say? P1 is the same as R2. Therefore, Q1 is the same as R2. So we can say then that S1 is the same as R2 plus Q2. Now, if you look at this R2 plus Q2, that's this angle and this angle. Now, okay, we're not saying that they're the same, but I'm just talking about those two angles. Now, if we know how triangles work, what do we know about the angle on the outside of a triangle? This one. Well, that angle that's on the outside must always be equal to the two angles on the inside added together, the two interior angles. So if you look at T2, which is the one that we're trying to find, that would have to then be, if you look at this triangle, whoops, that was an ugly triangle, T2 is then going to be equal to R2 plus Q2. So we can say that T2, or let's say it here, T2 must be the same as R2 plus Q2 because of exterior angle of a triangle. But now look here, S1 is equal to R2 plus Q2, and T2 is equal to R2 plus Q2, so those are the same. So these two have to be the same. So we can then say, therefore, S1 must be the same as T2. Not a nice question. That one's actually quite tricky. Okay, this next question for 5 marks wants us to prove that. Okay, so that could be like a proportionality or a similarity. So let's just go have a look at the sides. So AD AD, where are you, AD? AD is here. Okay. AR is there. AS is there. And AC. Okay. Okay, I don't think it's going to be a proportionality, because these parallel lines, it just doesn't fit. It doesn't look good. I would want those parallel lines to have rather been doing something like that. Okay, so I don't think it's going to be proportionality. I think it'll be similarity. So which triangles are standing out to you? Well, I can see the big triangle, and then maybe this little triangle. So let me show you carefully with different colors. So there's that one, and then this one. And let's just remember everything that's the same. So we now know from the previous question that S1 and T2 are the same. So S1 and T2 are the same. Let's do double things like that. And okay, and then P1 we also said, oh yes, we also said that that was the same as Q1. Okay, that's about it. So, right, let's see if this is the way it's going to go. So we know that this angle here would be the same because of common, right? So we could say that angle, or let's say the triangles. In triangle, okay, so the big triangle is ARC, and then the smaller triangle is ADS. We can say that angle A is the same as angle A because of common. Then the next thing we can do is, you see this angle, we know that it's the same as this angle, which doesn't really help us, but check this out. If we can say that T2 is the same as, well, they haven't really given us a name for that one, but we could call it like RTS. So if these two are the same because of vertically opposite, then we could use, oh wait, I've got a better one. Check this out. We could just use these parallel lines, and we could just use alternate over there. Haha. So we could say that T2, angle T2 is the same as angle C2 because of alternating angles, because the lines AC is parallel to ST. So that then means that this angle, you see, will then be the same as that angle. So that's good. So we can then say, therefore, C2 is the same as S1. Okay, so now that's great, because remember, with similarity, we only have to prove two of the angles, and then the third angles are always going to be the same. So what are the third angles? Well, in the purple triangle, we have not used D1, so we can say D1. And in this triangle, we have not used R1. And so we can just say sum angles triangle. Then we can say, therefore, triangle ACR is similar. Now make sure you get your order right. So now we're going to say A, and then C. C went with S1. So that'll be S, and then D. And the reason is angle, angle, angle. Now we make our ratios. So AC over AS equals to CR over SD, which is equal to AR over AD. Now here you could say corresponding sides in proportion, or you could just say similar triangles. Okay, now we want AD, so let's see, there we have it. We want AR, there we have it. We want AS, there we have it. And we want AC, there we have it. Okay, so we're going to take those two. So we're going to take AC over AS equals to AR over AD. And then you can just flip both things upside down and switch it all back to forth, and you should get AD over AR equals to AS over AC. Done. So we've done that question. Okay, with this question it says prove that. Okay, so we've still got the previous question's triangle written out. I by mistake erased everything, but I just went and wrote it out. I might have got this in a different order, but these are These are all correct, okay? So we've got that, and now they want us to prove this. Interesting. So what I would do first is I would circle AC, and I would see that we have it there. Then SD, okay, we've got it there. AR, oh, we've got that one there. Okay, so we've got all three of them. That usually actually makes things more difficult, because now we don't know which two we should use. Okay, so what I can see is that if I take these two, if I cross multiply, then I end up with AC multiplied by SD equals to AS multiplied by CR. So we've got this part. You see that? We've got it there. But this part's not what we want. So what I'll do is I'll look at AS and CR. So AS and CR. Now I think they're maybe going to use these parallel lines for proportionality. So AS is one of them, and CR is another. And then we also need a TC in our answer. You see that? So I'm going to use TC over, then I'm going to say this entire length, CR, and then I'm going to make that equal to, so the TC part, that would go with AS, and then the RC would go with AR. What I then do is I can see that there's an AS and a CR here, which I can get if I use cross multiplication. So I can go TC multiplied by AR equals to AS multiplied by CR. And now I can replace this, which is the same as this part, with this, because it says here that this is equal to that. So I can then say AC multiplied by SD is then going to be equal to TC multiplied by AR. And that's exactly what they wanted us to do there. Wow, that's a challenge.